All right, I'm on the practice question up here in the upper right. The rate of heat transfer between two liquids will increase if, and it says, assume single phase conditions and a constant specific heat. So here's what they're actually trying to do. Let's come here. So Q dot of the hot will transfer, the rate of heat transfer of the hot will be the same energy that's transferred into the cold. And it said they don't change phase. So what we're going to do is we're going to say, okay, mass flow rate of the hot and the specific heat capacity of the hot and the delta T of the hot, which is T hot minus T cold. So we'll do that just in case. Same thing, writing out like this, is equal to, and then over here it's going to be the mass flow rate of the cold water times C sub P of the cold times delta T, or mass flow rate C sub P, and this is all on the cold side and this is all on the hot side, times T hot minus T cold of the fluid. So let's see what options it gives us. And it said, assume single phase conditions. So this allows me to use these equations. Anytime you're using specific heat capacity, you can't have a phase change. And it says constant specific heat. So the specific heats don't change. Don't have to worry about these. So it says flow rate of the cooler liquid decreases by 10%. So if I was to reduce the flow rate of the cooler liquid, well, since Q dot is equal to that, heat transfer is going down. So alpha is not the answer. And when you get in your car in the middle of July or August, what do you do with the fan? You turn it on high because that's turning that air over and getting massive amounts of heat transfer. And this is a mass flow rate dominant equation. So that is definitely not the answer. If I want more heat transfer, I need to raise mass flow rate. Let's see next. Flow rate of the hotter liquid increases by 10%. So if I was to increase this flow rate right here, well, that would certainly raise heat transfer. I like that one a lot. Let's see make sure the other two are wrong. Because what I'm doing is sending more hot water to the heat exchanger with the same amount of cold. That's going to be turning the hot water in contact with cold more. So Bravo's looking good. That would result in more heat transfer. And it says inlet temperatures of both fluids goes down by 20 degrees, or inlet temperatures of both liquids go up by 20 degrees. Well, in that case, we're affecting both sides of the equation, and that's not going to do anything because it's affecting the temperature over here. It says inlet temperature here, and then this on the cold side is this inlet temperature here. Because it's cold and leaves hot, this is hot and leaves cold. So Charlie and Delta would have no effect. Answer Bravo. And that should be recognized that if you want more heat transfer, get more flow rate.